Hello everyone. This video is about building and running the iCube ExpressLink FreeRTOS example and issuing a host OTA and enabling the ExpressLink event pin in the FreeRTOS project. At this time, you should have your ExpressLink module registered at AWS IoT Core and you have your AWS CLI profile configured. I'll be using the BU585 IoT 02A board. However, the steps are applicable to any board supported by the FreeRTOS examples. To get to the FreeRTOS examples, simply copy this link path and paste it on the search bar. And this will open the FreeRTOS example on the iCube ExpressLink. Select your board. So here is the board that I'll be using today. And then double click on the IOC file to open it in STM32 CubeMX. Now all you need to do is set your AWS endpoint, your Wi-Fi SSID, and password. You can get your AWS endpoint from the AWS IoT console. So go to Settings and copy your endpoint. Go back to STM32 CubeMX. Here in Middleware and Software Packs, expand it and select iCube ExpressLink. So here you can set up your AWS IoT endpoint, your Wi-Fi SSID, and your Wi-Fi password. Then click Generate Code. This operation may take some time, so feel free to pause the video and then come back when the code generation has finished. Okay, so now I have the code generation finished, so click Open Project to open the project in STM32 Cube IDE. Okay, now the project is successfully imported to STM32 Cube IDE. Click OK. Okay, now select the project and build the project. Now the project is successfully built. Then we can start the debug session by clicking on the debug icon. Click OK to accept the ST-Link settings. Before I run the project, I'm going to open Serial Terminal to see the debug output. I will open TerraTerm, Settings, Serial Port, select my serial port, make sure my baud rate is correct, the data bit is correct, parity and number of stop bits is correct, and then click Open New Connection. Go back to STM32 Cube IDE and run the project. So I go back to the serial terminal and now I can see the debug output. Okay, so here we can see the ExpressLink module, the technical spec, and the firmware version. The firmware detected it's a Wi-Fi module and connected to AWS. Okay, and here we can see the firmware revision number, and the firmware is running from the Flashbank 1, and that the OTA task started, the shadow demo started, environment sensor task started, the motion sensor started, and PubSub sensor started. Let's go and monitor the MQTT messages being sent by the board. So in your AWS IoT console, click MQTT test client. Select this filter to subscribe to all the messages, and here we can see the messages being sent by the board. So I can pause so we can see the messages. So here we can see the accelerometer data, so the humidity and temperature, and also the hello world messages being sent by the pub/sub task. Now we'll issue a host OTA to update the firmware on STM32. So first thing, we need to understand the memory map on STM32. So there's a slight difference between if you are using a dual bank device or a single bank device. In my case, I'm using STM32U5, which is a dual bank device. So on dual bank device, so you have a section for the main application, and then another section for metadata, a section for host OTA, and a duplicate section of metadata. While in single bank, you have only one section of metadata. The metadata section contains the Wi-Fi SSID, your Wi-Fi password, APN, and AWS endpoint. So the Wi-Fi SSID and password and APN and AWS endpoint are kept separate from the application in a way to allow you to push new updates without worrying of corrupting the Wi-Fi SSID and password or APN or your AWS endpoint. Also, it's important to know the maximum application size that is unlocked. So, and this will depend if you are using a single bank device or a dual bank device. Here is the max host OTA's size formula. And here an example. So in my case, I'm using a 2 megabyte STM32U5. So my maximum OTA size is 1016 kilobytes. If you are using an STM32G071, your max OTA size is 62K. Before we create a host OTA, we need to create a signing certificate and upload it to AWS and upload it to our ExpressLink module. This process contains multiple steps and it will be long and difficult to do it manually. That's why we have created scripts to help with the process and reduce time and the possibility of errors. First thing we need to do is create a certificate and upload it to AWS. For this, we can use the generate cert script. Copy this path and paste it on the search bar. Locate generate underscore cert.ps1 and open it in a text editor. Check all the parameters for the certificate you want to generate. For now, I will keep all the settings to their default value. Save the file and close the editor. Open a PowerShell window and type generate cert.ps1 and press enter. Because AWS limits the number of certificates that can be imported to AWS, the script checks the number of the certificates that you have, and if you have more than 10, it will ask you if you would like to continue. It should be okay, as I think the limit of certificates is around 1,000 certificates. So if you are sure, then press Y to continue. Press Y and enter. And now we can see that the certificate was created and saved and you have saved two files, ecdsa.pem and ecdsi privatekey.pem, and the certificate was uploaded to AWS Certificate Manager service. Also, it prints here your certificate ARN, and also the certificate ARN was saved in the cert_arn.txt. So if you go back here, we can see the private key, the signing certificate, and the certificate ARN. So we'll need the certificate ARN for later. We need to upload the certificate to the ExpressLink module. This allows the module to verify the authenticity of the host OTA binary before informing the host of the presence of a new host OTA update. We can use the set host OTA cert script, but before we do that, we need to disconnect the serial terminal. So on the serial terminal, I need to disconnect from the board as the script will communicate with the board over serial. From the same PowerShell window, type set host OTA cert.ps1 and press enter. So the script will ask you to reset the board, so go ahead and reset the board. So this will take a little bit until the board restarts. Okay, so now the script will enable the pass-through mode, set the ExpressLink module to factory reset, send the host OTA certificate. Here it shows you the result of the operation. Read the host OTA cert back just for debug, and then everything is done. So once the script execution is done, you need to reset your board again. So press the reset button. Before I continue, I would like to show you a debug feature that is available in all the scripts provided in this pack. So go to set host OTA cert.ps1 and open it with a text editor. So here at the end of the command, append -d, and this will enable the debug mode. So save it and close it. Then go back to PowerShell and execute the script again. Reset the board, and now we can see all the communication that is happening between the script and the board. So here we can see all the AT commands that are being sent to the board and also the responses that are coming back from the board. So now everything is done. We need to reset the board. Now we can continue with the firmware modifications. So we need to update the revision number, and also in the case if you are using an STM32 H503 or a G071, so because of the flash size is small, so these are 128 kilobyte flash devices. Also, we need to enable the optimization, and also we need for all other projects we need to enable the generation of the binary file. So go to STM32 QBIDE, stop the execution, expand the tree, expand the include directory, and double click on the application version.h and change the revision number. And also you can do any other modifications you want. Then click on the project, right click and click properties. Select build settings, and then here in the post build outputs, select it and then check convert binary to binary file. Also you can enable the optimizations, so click optimization and set the optimization to the one that you want. So I suggest for the H503 and the STM32G071 to optimization for size maximum. Then click apply and close. And then rebuild the project. To continue with the host OTA, go back here and copy this link to the host OTA script and paste it on the search bar. Locate the host OTA update.ps1 and open it with the text editor. So here we need to fill in multiple informations. First thing, select your board. So this is my board. I need to uncomment it and comment this one. Your AWS profile. Also, you will need your thing name. If you don't know it, you can go to AWS, go to things, and you can identify your thing. So for me, I know this is my thing name, so I can copy it. So for role, you need to specify a role for assigning role. And also you will need to specify assigning profile, an S3 bucket. So the S3 bucket name should be unique globally. So for role, I'll choose a STM32 host OTA role. For the signing profile, I'll choose STM32 host OTA signing profile. For the S3 bucket, I'll choose STM32 host OTA S3 bucket. And also you will need your certificate ARN. So the certificate ARN, you can get it from this host OTA cert. So here you will find the certificate ARN, double click on that, and then copy the host OTA cert. Then go back here and paste the certificate ARN. Okay. So now we are ready to issue a host OTA. So we go back to the host OTA directory, open the PowerShell. Before we issue a host OTA, let's connect our terminal so we see what's happening. Okay, buffer, I reset my board. Okay. Okay, my board is connected. I will put these windows side by side. And then we need to call HOTA update.ps1 and press enter. So this script will create the role, will create the signing profile, will create all the required permissions, and also create the S3 bucket, uploaded our binary to S3 bucket, and created an OTA. So here on the console, we can see that the new host OTA update is being proposed. So Now the host OTA is being downloaded by the ExpressLink module. And once the ExpressLink module verifies it against the host OTA image that we uploaded to the module and verify it, it will inform the host that the new image has arrived. And here we can see the image is being downloaded. Okay, and now the device will reboot. So we see here in the beginning the revision number is 0.9.1 and the device is running from bank 1. So we'll see after the device reboots. Okay, so now we can see that our revision number is 0.9.2 as we set it in CubeIDE and that the device is running from bank 2. So now we can say we have a successful host OTA update. We can go to AWS console. So on remote actions, you can click on jobs and here you can see the jobs. So here on the top, you'll be the latest job that we have created. So this is job, we can click on the job execution and we can see that we have a successful job. And also you can verify here your thing name. Okay. So as we saw here in the terminal that the STM32U5 switched to bank 2 to run the new updates. However, if you want to continue and debug your application with STM32 CubeIDE, STM32 CubeIDE will have some hard time to connect to the device when the swap bank option bit is enabled. So we are going to disable that. To do it, open STM32 Cube Programmer, STM32 Cube Programmer. Okay, okay. Click Connect. And then in the option bytes, select User Configuration, scroll down, and here you will see the swap bank option bit. So uncheck it and click Apply. Okay, so everything is done, and then click Disconnect. Next step, we are going to enable the ExpressLink event pin. The main reason we have the ExpressLink event pin disabled in the FreeRTOS project because different modules have the ExpressLink event signal assigned to a different pin on the Arduino shield. And in order for us to have a single firmware and a single binary that can support different modules, for example, Wi-Fi or cellular, we had to disable it in the FreeRTOS project. With the ExpressLink event pin disabled, the firmware will constantly interrogate the module for new events without checking the ExpressLink event pin. This will result to processing overhead. So I will show you how it's working by enabling the debug mode in the ExpressLink driver. Select the STM32 CubeMX project, and here in the ExpressLink, in the parameter setting, in the ExpressLink debug, select debug level 2, and then click generate code. Okay, click close, and then in CubeIDE, rebuild the project. Okay, now we'll start a debug session. Okay, I have this message because My STM32 program is still connected to my board. So click OK. I'll go to STM32 programmer and click disconnect. Okay, so let's start the debug again. Okay, I'll go back to TerraTerm, clear the buffer, okay, and run again. And now here in TerraTerm, you will see on the debug information, here we see the AT commands that are being sent to the board. And you see here, there is a lot of AT events because the board is pulling for events from the board. So this is when the event pin not being used. Okay, I'll start the debug. Now we go to STM32 CubaMax. We search here on the top underscore ExpressLink event pin. So here it is. Click on it, and this is the pin. So right click at it, the label. So remove the underscore prefix and press enter. Then we need to enable the interrupts. So here under the category System Core, select NVIC. And here we have EXTA line interrupt. So we need to enable it and set the priority to 7. And then click Generate Code. Close. We go to CubeIDE. So in fact, in CubeIDE, there are sections of code that are enabled or disabled depending if the ExpressLink event pin is enabled. So for example, the GPU EXTA interrupt routine callbacks. When we call the ExpressLink event ExpressLink task, well, we enable it. Also, the ExpressLink tasks depends on we have two tasks. One that is called when we are use the event pin, or the other one that when we don't use the event pin. So I'll go ahead and build the project. So you see now this task is being enabled. So this one is used when the event pin is used. And also now the EXTI interrupts pin callbacks are being enabled. Okay, so I'll start the debug. Okay, and now I run the project. And here we see a less number of AT commands being sent to the module, and we call the AT events command only when there is an event that is triggered by the ExpressLink event pin. Thank you. So this will end the video. I hope you enjoy it, and thank you for watching.